Every day, a desalination plant converts 7 million liters of seawater into drinking water. Using a considerable amount of energy, they remove the salt from seawater in just 90 minutes. But how is seawater made drinkable? We visited a desalination plant to discover how drinking water is obtained. One solution to water scarcity is seawater desalination. This process involves removing salt and other minerals from the water to make it potable and safe for consumption. In regions where freshwater is limited, desalination plants remove salt from seawater, transforming it into drinking water suitable for human consumption. This plant converts 7 million liters of salty seawater into drinking water every day. There are more than 19,000 desalination plants worldwide that produce over 45 billion liters per day. The desalination plant that produces drinking water is located next to a power plant that uses seawater to cool its condensers. After cooling them, the water travels through underground pipes to the desalination plant. The plant makes seawater drinkable in just 90 minutes, surrounded by the sea on 3 sides. Here, there is no shortage of salty water. The challenge is how to make it potable. The water is treated in a multi-phase process before salt extraction. The desalination process begins with the intake of seawater through open intakes. A strategic location is chosen to ensure a constant supply of high-quality seawater and minimize environmental impact. Seawater is drawn several hundred meters from the coast. Grates and filters block large floating objects and prevent marine life from entering. A 63-centimeter diameter pipe extracts 15 million liters per day. That's more than 10,000 liters per minute or a bathtub every second. At the intake, pumps are needed to push the seawater to the plant. As seawater is drawn in, some unwanted visitors appear: mollusks, jellyfish, crabs, and sometimes small fish. To prevent these small creatures from coming out of our taps, a giant grate screens out anything larger than 4.5 millimeters in diameter. The water passes through screens that filter out larger debris. Even after these creatures are removed, the water is full of small particles of suspended sediments. The solution is a process called filtration, which takes place in these tanks. Water particles pass through sand beds by gravity. The gaps between the grains are so small that only water can pass through, leaving behind any suspended particles. The sand moves downward against the water, and dirt particles stick to the sand. It may look clean now, but it still contains microscopic particles. Every particle larger than 1/10 the thickness of a human hair is removed. Next, large paddles stir the water, and the plant adds 2 chemicals: sodium hypochlorite, a disinfectant, and ferric chloride, a coagulant. The coagulant binds the waste and sand, forming larger clumps that sink. A large portion of the dirt is removed from the